Hi, folks. Welcome to Azure Kubernetes Service Operation Best Practices. My name is Umar Mohamed Usman. I am a principal engineer, part of Fast Track for Azure team under Azure CXP Azure Engineering. I help customer architect and deploy applications on Azure. Srini?
Hi everyone, this is Srini. I'm an engineer on the Fast Track for Azure team.
All right. Along with us, Marcos Martinez joining as well. He'll be moderating our chat and he'll be answering all your questions via chat. Feel free to say hi to him. And here is all the content we'll be presenting today throughout the session. And you can see all the links, the architecture diagram, and along with the learning modules, the videos, you can find them in here. Before I jump into the learning objectives, in this session, we'll cover Azure Kubernetes Services operational best practices. We will be looking into how, as a Kubernetes administrator, you will be managing your cluster, some of the best practices, some of the tools and demos tools that you can use to manage your Kubernetes cluster. And this is not a session, introduction session, not a session to design and deploy. This is more focusing on operational aspects of it. So when we go through learning objective, you will get the hang of it. So we'll assume basic introduction knowledge of Kubernetes. And with that, the first thing we'll look into it is how resource management works in Kubernetes. For example, when you deploy pods, how would you define your resource limits and requests? And also, when a load increase, how would you auto scale the pods as well as nodes? So that's what we will cover under the resource management. Then we will move on to patching and upgrade. During this section, we will be covering how you would patch the nodes, as well as how when a new version of a Kubernetes, upstream Kubernetes version available, how you would upgrade that to the new version of Kubernetes. Finally, we will touch on business continuity and disaster recovery. Under this topic, we'll cover how you can deploy a Kubernetes cluster across availability zones. If that is not good enough, how you can deploy across regions, as well as we will look into how you would handle like dependency service such as Azure Container Registry when a disaster hits, how would replicate images to another region. So that's the high level learning objectives. Along, so now we'll jump into the architecture. This is the high level architecture of Azure Kubernetes Service. As you may know, Azure Kubernetes Service is a managed service. That means it offloads significant operational overhead from you as an administrator. So while it is a managed service, it is not a PaaS service like an app service. What does that mean? PaaS services are generally managed by Microsoft. It's fully managed. You don't have to log in RDP into the VM and all of that. But whereas Kubernetes is a managed service, that means the control plane of the Kubernetes cluster on the left-hand side is managed by Microsoft. On the right-hand side, the agent nodes where you will be deploying your workloads, and it is managed by you as a customer. So you are responsible for patching the VMs and rebooting the VMs and all of that. Besides that, you're also responsible for upgrading a version from when a new version of a Kubernetes is available, upstream Kubernetes version available, you're responsible for upgrading that as well. So so we divide the responsibility between Microsoft as well as you as a customer. So it's not a PaaS service, so it's a managed service. Keep that in mind. And also, you are responsible for, of course, deploying your applications and making sure it's highly available and scalable and all of that. There are lots of best practices that we're going to go through, but keep in mind it's not a PaaS service; it's a managed service. Okay. With that, I'm going to hand it over to Srini to cover resource management and patching and upgrade sections. Then I'll come back and talk about BCDR. Srini?
Thanks, Umar. Let's switch to my screen now. So when we talk about Kubernetes, one of the core objectives of Kubernetes is optimizing resource utilization. So we want to optimize the underlying hardware at the same time ensuring that all the workloads that are deployed on the cluster are getting their due share of resources. So it typically happens when you're using a Kubernetes cluster, you share a cluster maybe across teams or across application services. So you want to make sure that each and every workload out there on cluster are getting their fair share of resources. So it's important because in a shared environment there could always be a pod which goes out of control, or there's a rogue workload out there which is trying to disrupt the whole ecosystem. So in order to avoid such kind of noisy neighbors, it's extremely important to have certain guardrails in terms of resource consumption, right? So how do we achieve this, right? When we go about talking how to achieve this, Kubernetes has a built-in set of constructs, specifications to make this possible. And request and limits is one such construct out there, which will help us control the amount of resources that a particular pod can consume. So let's look at an example of how it looks like. Uh, the specification YAML itself is going to show what what resources are required. So if you look at the specification, this is an example of the specification YAML. So whatever that you see here, the requests, the limits, they are the ones which define how much amount of memory or CPU that this particular part can consume. Now, again, what these requests are, so whenever you start a pod, it needs to start with a default set of resources. That's what reflects in the request. The request denote as to what are the default set of resources that this workload requires to start. Whereas you also need to have a threshold saying that, okay, it's not just that my pod can keep using as much of resources that it would want, but there should also be a threshold that has to be applied on that particular workload. That's what these limits are. So the request denotes what are the default sets that it has to start on, whereas the limits defines what is the threshold that it can go up to.
So this is pretty cool, Srini. And is there a way that we can enforce, every application deployment that we deploy, those parts should have certain request and limit? Is there a way to enforce it?
Yeah, definitely yes, right? So enforcing governance, you can achieve this particular thing in multiple ways, right? There are two primary ways we will talk about in this particular discussion. One is a Kubernetes way of doing it. The other one is a more an Azure native way of doing it. The Kubernetes way of doing it is enforcing resource quotas and limit ranges, whereas the Azure native way of doing it is more through Azure policy. So when we go into the details of each of it, we will talk a little bit in detail about them. But the the resource quotas, right? To start with the Kubernetes way of looking at it, the resource quotas are some things where in a shared environment, say suppose you have a shared environment, you wanted to apply you want to ensure that each and every resource in your shared and each and every resource in your shared environment. Say suppose you have like three teams sharing a Kubernetes cluster. If three teams are sharing a Kubernetes cluster, you want to make sure that each and every team is allocated a specific set of resources. The resource code is nothing but the same specification, which lets you define saying that, hey, my team one can take like two CPUs out of my existing existing hardware, whereas my team two can take one of it. The resource quota is more or less which specifies how much amount of how much amount of CPU or memory or GPU for that matter that a particular team can consume. So if you define this and deploy it in a particular namespace, it ensures that all the workloads that gets deployed on that namespace, say suppose a team is deploying it on that, uh, you have all the workloads that the team is deploying in that particular namespace should add up to the request and the limits. So that's what the first guardrail is. So it doesn't mean that this alone will satisfy your need of protecting your shared interests, right? Because within a team as well, you might have a team which is deploying 3 services into their own namespace. So we also have to make sure that each and every workload out there also has a decent behavior defined on it through the requests and limits. So
Yeah, I was
the
thinking the
next,
same, Srini. The moment you give it at the namespace level, maybe multiple applications sharing the same space or different components sharing a same namespace, what if one of the components decided to take up all the memory or all the CPU limit that's defined at the namespace level? How
very
would you?
true. So
Yeah.
that's what our next segment is, which is limit ranges. The limit ranges are the one which kind of enforces the resource requests and limits we have kind of talked about at the beginning. So what this limit ranges does is it tends to it serves two purposes. One, in case you haven't specified any requests and limits on a workload, and if you try to deploy it, it automatically applies certain defaults to it. That way, it is safeguarding the neighbors by just restricting a particular workload to a specific threshold. Other than that, you can also specify a max and min. What this max and min means is, so when you're deploying a workload, Kubernetes checks if the workload is coming with a limit value which is between the min and the max that are specified in the limit range. So combined, the resource quotas and limit ranges, they kind of serve as an in-cluster safeguards for resource management within a Kubernetes cluster. So we talked about the Kubernetes native way of doing it. Let's look at an Azure native way of doing it as well, right? So a Kubernetes way of doing it, there's nothing wrong in doing it in that particular capacity. But again, when it comes to scale, say suppose you have like 20 or 30 clusters to do the same thing across, it is a little difficult for you to consistently apply the same kind of guardrails across your clusters. That's where Azure policy comes into play. Azure policy is a general governance tool where it applies rules or policies consistently across different Azure resources. The same applies to AKS, but it's a little special for AKS because it extends it a little bit by also making sure it safeguards the cluster internals, like at the workload level as well, not just governing AKS as a whole, but also within the workload as well. So that's what Azure policy brings in with the help of open source projects like Gatekeeper and OPA, which combined with admission webhooks, they will validate each and every workload that is being passed through the API server, ensures that it is as per the rules that are defined by the policies, and either accept the deployment or deny the deployment. Let's look at how Azure policy look like. So if you're just going back to to the Azure portal, when the Azure policy blade, we can land into the Azure policy blade in two different ways. Either you can land it from the individual resources that you want the policy to be applied on, or generally by just typing policy in your top search bar. So when you search for policy in the top search bar, uh, you see policy in here, you land into the policy blade. So this is the generic blade which applies to all the resources, not specific to it. Now we need to introduce you to two different specifics of policy, right? uh, there are there are policies which are the lowest unit, the discrete unit, which are nothing but the rules that gets implemented on your specific resource. Now, there is also another construct called as initiatives. What these initiatives are, they're nothing but a set of policies. They're grouped together in order to achieve a common objective, right? You might want to achieve a common objective, so that you group them together as one initiative and apply that initiative to a particular resource, as opposed to doing individual policies. So for the sake of this discussion, let's go back to the definitions to look at what are all the policies that are available for for Kubernetes. Uh, when you click on the definitions, you can search for uh, you can search for all those. Uh, you can search for the definitions in here. Let me just get that in a brief moment. And I can also take you through the list of policies and initiatives that are available within a particular Kubernetes cluster. Let me bring that up in here. So you can look at these initiatives. These are all the initiatives that are available for Kubernetes. What these initiatives are nothing but, if you are aware of pod security policies earlier, we have the new pod security standards defined by upstream Kubernetes. The pod security standards are nothing but a bunch of rules, uh, the bunch of rules which are categorized as three different segments. One which is unrestricted. That is the privileged one, and then there is a baseline, and there is a restricted set. So this effectively is a bunch of policies or rules, for that matter. If you want to go deeper into what each of these means, it has a bunch of controls. Each against each of the specification, there are a bunch of rules that specify how to create a secure workload deployment. So the built-in initiatives that are available for Kubernetes in Azure policy is nothing but a translation of those pod security standards. You just see that there are two of them here. There's a baseline and restricted, because the privileged is like do it all. So there's no rules that are applied to it. So it doesn't really matter, because there are no rules to it. So effectively, we will end up in two initiatives, which is the baseline initiative and the standard initiative. Also, we have policies which are which are across different resources. Now, when we have to look at specific to Kubernetes, we have both AKS specific policies, as well as uh, in cluster ways. So there are two different categories in here. One which applies to AKS as a resource as a whole, and number two, very specific to Kubernetes deployments. So I can when we scroll down to look at what kind of Kubernetes policies there are available, you can clearly see that there are a host of policies kind of that are meant to secure the deployment of your Kubernetes clusters. Going back to the Azure portal here to show you oh, the definition details of that Kubernetes cluster. From you just go in and look at the overview. Just let us give it some time to refresh.
While it's refreshing, Srini, if I were to sum it up, in order to enforce these limits and requests on a pod, you could do it on a Kubernetes namespace level and also apply the limit ranges. And Kubernetes allows you to do that. And those are Kubernetes objects. But then you also have a policies, native Azure way of limiting that as well. So would you recommend one over the other, or would you recommend both of them? What is your best practice that we recommend to customers?
So So it depends on what your particular circumstance is. When we are dealing with individual Kubernetes clusters, right? When you're doing policy at scale, you might not have the flexibility to do it individually or tailor it down to a specific team. If you need absolute control, that's where you resort to using Kubernetes native limit ranges and resource quotas, because that gives you a much more control in terms of versatility on doing it across different teams and different resources. But if you are specifically looking for scale related policies, if you want to do it at scale, definitely Azure policy is what you need to look at, because once you apply it at a specific scope, the scope could be like individual Kubernetes cluster, or you can just say that apply this particular policy across all my clusters in my subscription. That's a possibility as well.
So you can apply at
So,
the resource group level, subscription level, or at a cluster level, right?
right.
Perfect.
So let's look at a demo here. I've applied one of these policies in here. Let me look at the portal to show you what it looks like. But I have applied one of it. Uh, that'll come to it a little later here. But I have a workload in here, which is actually trying to deploy a particular deploy a particular Nginx pod with requests and limits specified. So I've deployed an Azure policy for CPU and memory with certain limits that are applied on it. I've said that okay, I wanted CPU and memory requests to be set on that particular pod. So when I go about applying this pod, so let us
So
go
you're
ahead
basically
and
requesting Srini 64, sorry, 150 CPU
millicores,
core
150
millicore
millicores of CPU and 64 MB of memory
64
on that
memory you're
particular
requesting.
part.
And the
Yeah.
maximum would be 128 memory, then 650
E-
CPU,
Yeah. So when
right?
I try to apply this deployment, uh, that deployment should be validated against the policy that I have deployed into my Kubernetes cluster. Just wait a moment for it to reflect in there.
Looks like your environment is kind of slow today.
Yeah, yeah, it's kind of slow, but again, if you see that it came back with a particular error. So if you go into a little detail as to what that error is actually specifying, it is you're trying to deploy an Nginx container with CPU limit of 650 millicores, whereas whatever the policy that you have specified, the guardrail that you have specified suggests that it has to be 600 millicores. So the actual policy kicked in here and stopped you from deploying that resource because you are actually requesting for resources more than what is assigned as a guardrail by your administrator on the cluster. So if I go back and update this to reduce it to like 600 here, i should I should be able to deploy this and be in line and be in line with my organization policy that was set at a
Make sure
cluster
you
level
say
here.
it
So
again. Perfect.
let's just go ahead and show and run the same deployment again, just to make sure that the policy is in fact working in this particular scenario.
Perfect. So this is a
So
perfect
what?
toolbox for the administrator, Kubernetes administrator in their belt to manage their environment so that it is not being, that noisy neighbor scenario. All of a sudden that, somebody is
Yes.
deploying, taking up all the resources and starving other applications, right?
Very true, very true. You can see this now that the Nginx part is created here, and the policy that we have applied is in fact applied back to our Kubernetes cluster here.
Awesome.
Right. So going and the next aspect that we wanted to talk about is how do we actually monitor these, right? So now we have
Yeah,
enforced
that's the
guardrails
biggest
to
question.
deploy them.
Our customers do ask, right? Hey, now that I have set it up, do I really know the amounts and the limits I have set up? Is that really being used, or is it really being used low? The pods are not really using the full resource CPU limits and the memory limit that you have assigned. Is there a way to monitor? I'm assuming that's what Container Insights allows you to do that.
Right. Yes. So just enabling guardrails is not good enough for you to operate a Kubernetes cluster. You need to continuously monitor and observe and also be able to be alerted as and when there is a certain incident that happens on your Kubernetes cluster. The Azure way of doing it is container insights. This is an extension that you could deploy on a Kubernetes cluster. Uh, Again, when you enable that, it will give you a host of information for you. Let me go back to your portal, and it's the standard way of doing it, right? So similar to how you monitor any other resource in Azure, it gives you a single pane of glass to be able to monitor resources across your Kubernetes estate. It's not just like one resource, but it's across the Kubernetes estate. You can go ahead and and into the container solutions to see what are all the clusters which are monitored in my subscription versus what's not monitored. So you can see the unmonitored clusters and the monitored clusters. And if you jump right into your monitored cluster, you'll be able to see insights ranging from at the cluster level, the node level. You'll also be able to see insights at the workload level, at the container level as well. Now, when we see this, as we go along, when we see this detail, uh, just getting here. So when we go into the individual cluster detail, we also have a set of recommendations on the alerts that you can deploy on this specific cluster as well. So at a high level, I've talked about what are the cluster insights that you could see. You can see the cluster insights, which are more specific to cluster. You can see reports, which are, if you are looking for a specific metric that you wanted to dive deeper into, you could run these particular set of reports on the metrics that were collected. Similarly, you can get a lot of analytics at the node level in terms of CPU memory, and the same with the containers as well. So this is what is going to give you those visualizations on the metrics that are created, not just ensuring that you have guardrails deployed to for a safer deployment, but also continuously monitoring how the usage of each and every workload is going to be. That coupled with the recommended alerts, if Azure Monitor packs in a default set of alerts in here, you can enable them as you depending on what are those specific alerts that you are interested in, and then enable them and get notifications as and when that specific event is triggered. So it's always recommended that you deploy a combination of container insights on your cluster, at the same time enable the recommended set of alerts, or if something doesn't meet your requirement, create new set of alerts from the metrics that are collected from within your Kubernetes cluster.
So you basically deploy these container insights or enable the container insights and monitor the usage of the pods, how it's consuming the CPU and memory. If it's hitting, it's consuming 100% of what I had given, and I can really go and say, hey, this definitely need more CPU or memory, then I can increase those limits, right?
Right, yes. So you can manually do most of that. uh, for you to decide on whether you are consuming it right or not, you can always go back to container insights and look at, hey, my container is not consuming whatever that I have set as a request and limit on that, right? And that gives you insights as to how to manually adjust. But
Yeah,
there's
the
also an
biggest question.
automated way of
Yeah,
adjusting it as well.
I was going to say biggest question customer ask is, hey, what are the ideal limits for this, right?
True.
I'm going to make a guess out of it. Okay, this is my CPU limit. This is my memory limit. I don't know really until I really hit that load coming in. All of a sudden, that Black Friday load coming in. And are there tools that I can help me to deal with that
Definitely.
ideal limits?
Definitely, definitely. Yes, that's where, right, the container insights approach of monitoring that and resizing it is more manual, but it would always be good to have something automated. That's where we have the vertical part autoscalers on the upstream Kubernetes. Though it's a preview service in AKS today, but you can make great use of the vertical part autoscaler. So what the vertical part autoscaler, let's look at the vertical part autoscaler in a small demo here. So in this case, I have a smaller deployment, which actually sleeps continuously. And I have specified, I don't know how much memory or CPU that I need to allocate to this particular resource, but I have arbitrarily provided some numbers in here. So I need assistant. Either I can go to container insights, look at how it is using, and say that, hey, I need to bump it up or bring it down. That's one way of doing it. But there's also another automated way of doing it through the vertical part autoscaler. So the vertical part autoscaler is just like a pointer to your deployment that you have created and specify an update mode. So what this update mode does is it can either audit what are the values and just give you recommendations, or it can also go an extra mile in terms of updating the deployment with the required values. So this is even more useful when you wanted to do things more automatically. So let's look at a demo here and dive into how this actually works. So for the first thing is I'll have to apply the deployment that I'm going to do. So I've just applied my Kubernetes deployment here, and let me keep a watch on how the pods are being created.
So
So the
this is pretty
deployment,
cool. So we always had the horizontal pod autoscaler, right? Which adds more instance of a pod. Like if you're running two instances, then I need more load. I can add like two to four, four to five, something like that. I can add additional scale out. Now, vertical pod autoscaler is going to increase the limits of my CPU and memory.
it's
So it's
not just
scaling up,
about
right?
increasing the limits. It could be decreasing the limits as well. Say
Oh,
suppose you have over provisioned it without knowing what it actually takes, and if it is not consuming like anywhere near to that, the vertical part autoscaler will kick in, and it updates that to reduce those numbers. So that way it's a win-win on both sides.
perfect.
So now that I have created my deployment here, my parts are running. Let me apply the vertical part autoscaler here, uh, and wait for what's going to happen here. So I've applied my vertical part autoscaler, uh, and 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 we'll have to see what is that the vertical part autoscaler is doing. As I've said that it can do it in two modes. It can bring up the recommendations, or it can automatically update the workload in this specific scenario. So if you want to look at what uh, how to look at the recommendation, you just have to you just have to go in and view the definition of it. Let us go and look at the definition of it. So if you are going in and looking at the definition, you see that there's some activity happening on your right where a container got terminated and it got recreated. So just misspelled my name, apologies. So let me get in here. So if I see here, my actual definition is just this, but when I get the new definition that was in on the Kubernetes cluster, I have some additional information attached to it. So this is the recommendation that it is making. So though you have asked for in your actual deployment, you have asked for a 128 versus 200 for your limits. Um, Here it is what it's saying is, hey, you said 200 millicores for your CPU, but that's not what it is needed. It just need 25 millicores, whereas you need more memory. You're requested for 200, whereas you would need 262 MB. So that's what the recommendation here says. So because we have set that as auto, we expect that the actual part definition gets automatically updated for it. So let's look at one of the pod definitions that we have here. Let's pick this pod in here and see if it reflects the newer recommendations that were made by the vertical pod autoscaler. So when we're going in here, let's look at what is the requests and limits that are set on this specific one. So if you
Perfect.
see this here, these are different from what you have set in your deployment. So what happened is the vertical part autoscaler was monitoring this deployment. It saw that it needs renewed set of requests and limits. It went ahead and applied those limits onto those deployments. So this is the kind of automation that you could achieve if you are unsure about the requests and limits that that you have to set on a particular workload.
This is awesome, Srini, and it's a great tool to have in Kubernetes administrator built. It's awesome. So there are like looks like a bunch of checklist kind of items. Are there easy way to keep track of all these best practices in there?
Right. Yes. So typically, when we do a particular review with AKS or an Azure, any Azure resource, we have we go through a particular tooling, right? We have a public tooling that is available here, which is part of the AKS review checklist, which has a bunch of instructions that are outlined there. So this particular service, anybody can use it. It's available publicly. They can go in here and look at review your Kubernetes cluster across different operational areas. So if you are very focused on operations or BCD or security costs, you can definitely come in and you can look through all these recommendations that are available here. There are a host of them. We might not be able to discuss all of them, but some of them are important to us here. So we will definitely look at those few here, where we obviously say that have an isolated system node pool. That's important because you don't want your workload interfering with your stability of the cluster. The cluster components are
Yep.
reside in system node pool. We want to make sure that they don't interfere with your system operations. So that's one of the recommendations in the checklist, and the couple more like
Hey, by the
your
way,
sorry.
on the tool, the review checklist, I really like that checklist because I've used with the other customers as well, to going through their cluster. Have they done this? Have they done this? Like giving a checklist thing. What was the link again? aka.ms slash.
It's aka.ms/FTAAS as a service. So if FTAAS, you should get that link in the chat as well.
We'll make sure that we leave that link on the description as well.
Yeah. The other few things, maybe from an operations perspective, make sure you don't install any custom software on your nodes. It's very difficult for you to have that deployed across all your nodes because the nodes are ephemeral in nature. We take them down, bring them back up for operational reasons, upgrades, so on. So it's always important, if you want to deploy something across all your clusters, do it more in a Kubernetes way of doing it, like your daemon said like your daemon set, which ensures that there's a pod that is running in each and every node on the cluster.
Yeah, that reminds me of that pets versus cattle analogy, right?
Right.
Your VMs are your pets versus the Kubernetes nodes are more like a cattle. Like, you dispose them, or when you add a new node. And if you add a new node, if you have customized anything by RDPing into or SSHing into the node, and that's not going to carry forward into that new node, right?
Yeah,
So you want to use this Kubernetes way of doing it, which is using a daemon set.
definitely. And
Perfect.
also, one of the last recommendations here, again, you can go through the review checklist. One of the last recommendation is here, you need to size your nodes appropriately. Make sure they're not small, they're not large, depending on what kind of workload you're deploying. Make sure you have a decent sized node, which can let Kubernetes manage those resources automatically for you without underutilizing it or over provisioning it.
Yep. Perfect. It's that's the one of the common ask is there's no right answer. It's going to be a trial and error thing, and depends on what kind of application that you're running. Is it a memory intensive or CPU intensive? Select based on that requirement and node, and do a trial and error, do a test, load testing, then come to a conclusion on this is the right size of the node.
All right.
Perfect, Shini.
Sure. So let's move on to our next topic for the day, which is patching and upgrade. So when we talk about patching and upgrade, like Umar mentioned at the beginning of the call, it's a shared responsibility. We do something as a part of Azure. We let the customer do something as a shared responsibility. So the two important aspects from an operations perspective for AKS are, one is patching the worker nodes itself. Then the second one is upgrading the Kubernetes version of the cluster. So we'll quickly go through each of these aspects and identify what are the opportunities for us to make the operations process a little better. To start with, let's talk about patching. Again, we have when we talk about patching, we have two aspects that we need to take care of in patching. One is the OS patches itself, which are automatic, right? You can't control them. They keep coming as on a daily basis. They get installed on your worker nodes automatically. The second one is image updates. So these AKS ensures that you have a newer image, newer OS image with all the right patches till date available on a weekly basis. Again, this is not automatic. It's up to the customer to decide whether they wanted to move on to this node image or not. So one is automatic, where you don't have any control of it. The second one is on a weekly basis, which is completely in your control, and you can decide when you wanted to deploy it or not. Now, if you have to go into a Kubernetes cluster and see how you actually go about doing it, so there's certain nuances that you need to be aware of when we are talking about node patching and updates. Though the patches gets installed automatically on a daily basis, but some of the patches might require reboots. So
Yep.
AKS in no capacity does any reboot. So it's the reboot is up to you. Again, if you notice that there is a reboot required on a particular node, it's up to you to go ahead and reboot that particular node. But when you're talking about node image updates, you can come to the portal, select the node pool that you wanted to update your image for, and click on the update image in here, which will take you to tell you that, hey, what is the current version that my node pool is on, and if there is a latest version that is available, it will highlight the latest version and let you update that particular image. So there is a shared responsibility here. Some updates happen automatically, some doesn't happen automatically, but still you may have to you may be responsible for updating it manually or rebooting the nodes as and when required.
Yeah, instead of rebooting it, are there ways to automate this reboot, at
Uh,
least for lower environment, right?
Definitely, yes. It's not very practical when you talk about these as operational aspects to do a lot of manual activity, either rebooting the nodes or manually going in and updating the node images. So that's where our recommendation is to deploy a daemon set based on an open source component called Curate, which would actually identify that there is a reboot required on your nodes, and then be able to update or reboot that node when it is required. So all that it does is whenever the patches are updated, AKS will indicate it at the system level by creating a file for reboot required, and this daemon set simply looks at that file and automatically reboots that machine at a time of your choice. So depending on how you configure this daemon set, it will be able to reboot that. So Curate is our recommended way of handling patch reboots. Uh, when it comes to node image updates, because that's
On that,
more voluntary.
hey Srini, on that QRED, are there ways I can customize it to reboot on a certain time, right?
Yes, definitely. Yes, the Curate, you can refer to the open source Curate project. It has all the details on terms of how you can set a schedule to reboot your machines at a particular day and time of your choice.
Perfect. Is it like a more like a cron job type thing that you schedule a time and I want you to
Yes,
reboot? Perfect.
it's more or less the same. Yes. Coming to the node images, again, our recommendation is to use some kind of GitHub actions. Again, once you have when you create a GitHub action, you can use the ARM API to upgrade your node image on a regular basis at a time and day of your choice. So our recommendations for automating node image upgrades is through GitHub actions.
So one other question I often get asked by a customer is, can I just do the node patches or can I just do node image updates in a weekly basis rather than doing this patching or rebooting this every day or
Yeah,
when
it's
needed?
definitely a possibility, right? Yeah, if you are resistant to change, you tend to just keep doing what you are doing, be on patching the nodes on a daily basis. But you will miss out on two things if you keep doing that, right? each and every node image that AKS is going to release on a nightly, on a weekly basis, that's going to have the newest OS and the right security patches on it. So it's always recommended to take take an opportunity to upgrade to the latest image. The other challenge I've talked to customers is when they create new instances on a node pool. So if you are on a node pool, if you are auto scaling your node pool for whatever reason, a node gets added, but the node gets added with the older image and it starts applying all the patches from the day the node was created. So it
So
takes a little
basically, it's going to
longer
delay
for
time.
you to have the node available for scheduling. So that's another reason why I would always recommend customers to get on to the latest available node image on a timely basis.
So basically, it improves the performance of when you auto scale your nodes. When you add,
Definitely right.
uh, it adds quickly the new nodes
Yeah,
so that
it's
you
secure,
will
stable, it's more operational.
perfect. Are there other things that we should consider when this being patched and updated?
Definitely, yes. So there are a lot of considerations that you can that you can make while you are upgrading it. Again, when you are updating, when you're updating that the nodes, just make sure that you take your application availability into consideration. So whenever you are updating a node, by default Kubernetes does one node at a time, so it updates one node at a time. But again, if you are having a cluster with 100 nodes, you would like take a decent amount of time for you to update all the 100 nodes, so you might want it a lot more quicker. So what happens is maybe in a lower environment you might want to have it at a much faster pace, rather than you have your support personnel sitting there through the entire duration of your upgrade. So that's where max surge comes into play. So the max surge is a setting in the Kubernetes in AKS which will allow you to control the number of nodes that can be drained simultaneously. Say suppose if you have a 6 node cluster, and if you specify a max surge of 33%, which is one third of your nodes, that means you are creating two additional nodes, getting them ready, and then draining two nodes at the same time. So that's what is happening. So you can do 100% surge as well. That means you are draining all your 6 nodes at the same time, but that would land into application disruptions because you are draining all the nodes at the same time. So take a cue of the max search, see what makes more sense. You have to strike a balance between the time it takes for you to upgrade your Kubernetes cluster versus the availability requirements that you have for your applications. So max surge is something which you can definitely look at when you're upgrading clusters. So the other aspect, right? We talked about max search. We talked about the speed of an upgrade. You might also want to look at the availability of the application. So if you are draining so many nodes at the same time, you run into a risk of your application going unavailable. So that's where you will have to loop into an upstream construct called as part disruption budgets. Part disruption budgets are more a Kubernetes way of telling the Kubernetes server not to drain a particular node if my application is supposed to be unavailable. So you can specify that in two different segments. You can refer to the Kubernetes IO documentation. You can specify uh, it as min available or max available. So either of these cases, right, when you're specifying min available or max available, you are telling Kubernetes cluster is, I wanted a minimum of X number of instances on my pod, or you wanted max unavailable, which says that, okay, if I have like 6 instances by default, I can't afford to lose more than two of them. So that's the kind of setting that you're going to do. So what this does is, even though AKS attempts to drain a particular node, Kubernetes interrupts that process because it is not satisfying the pod disruption budget that is set on that cluster. So pod disruption budgets are definitely an instrument you would want to look at for making sure that your application is available even during these upgrade processes.
So it's
Again, and
basically the pod disruption budget ensures when we are updating this, my application is up and available running. It's continued to serve the business. Is that
right.
correct, Srini?
Right,
Perfect.
yes. So again, you can work with the power disruption budgets. Again, you might have even more critical work requirements saying that no, I can't afford to lose any performance. My QoS is very high. I can't afford to lose any of them. That's when there are other strategies which we could deploy, like your blue-green strategy, create a brand new node pool, deploy your application, route all your traffic to the new node pool, and then retire the older node pool. So there are ways in which we can strike a balance between what is that I want. Do I want maximum application availability, or do I want faster upgrades, or do I want somewhere in between? So a lot of these factors comes into play, but you have different options on how you can upgrade your clusters to the latest and greatest. Again, the last but not least in the Node OS is, again, if you think that even you want an even automated way of doing it, there is a newer in cluster native way of upgrading node images, which is subscribing to an auto upgrade channel. We'll talk about auto upgrade channels and planned maintenance window a little later when we're talking about the cluster upgrades, because the process is the same. But definitely look at those channels as well to ensure that you are automatically upgrading to the latest image. Uh, Moving on to cluster version upgrades. Again, we talked about node upgrades, right? We're talking about OS patching, updating the node image. You also have to regularly upgrade your Kubernetes version. Again, when it comes to cluster, that two you have two options here, right? You have two operational areas here. One is cluster updates and cluster upgrades. Uh, what cluster updates means is updating your kube system components or kubelet or API server components. This is what cluster updates are. They happen on a weekly basis. They happen without your notice. You don't have to do anything, unlike patches. You don't need any reboots or anything. They happen seamlessly behind the scenes. So though there is no action item for you for cluster updates, you need to be aware of them, because you need to know that when they happen, that something is happening on your cluster, which we will talk about in a little while. So the other important aspect of cluster versioning is upgrades, right? Upgrades are more voluntary, right? You have to opt in for the upgrades. You have to opt in for the upgrades for various reasons, because we don't support a Kubernetes version forever. So there is a specific version policy that AKS supports when it comes to Kubernetes. So uh, there would be a GA version. So we always support N-2 versions of Kubernetes, and we support two patches within a particular version. Um, So what this N-2 policy means is upstream Kubernetes, as you see, as it stands today, you get a newer version of Kubernetes roughly every 4 months in an year. Now, when we actually GA that particular version in AKS, we ensure that we support two versions behind that GA version. Say, suppose if I have GA 117 in Kubernetes in AKS today, then we'll support 116 and 115. And within each of the version, we support two patch versions. So we continuously release newer patch versions as we see that there are security findings that are identified. We fix certain aspects of that particular Kubernetes version. So we only support two minor versions, and two patch versions within each minor, yeah, within each minor version. And you have like 30 days for you to upgrade to the supported version. So if you are in 114 today, you have 30 days from when that was deprecated to get onto a newer version for you to be within the within the supported version. And again, failing that, you will fall outside of the support. What it means is, if you have to call support for anything on that particular cluster, the first thing you will be asked is to upgrade your cluster, and for it to be able to be supported.
So Srini, if I'm not calling a support and I'm beyond N-2, I'm in an older version, can I continue to be on that version?
You can continue to be on that version with a little caveat here, right? So if you think if you are on a deprecated version, and if we find that there is a critical vulnerability in that, so we will try to reach to you saying that, hey, you are on an unsupported version, there is a critical vulnerability, you need to upgrade. If you're still not acting on it for the safety of the overall AKS ecosystem, we automatically upgrade that cluster because we are not hearing back from you on that particular critical vulnerability.
Perfect. Are there better way or easy way to handle these cluster upgrades?
Definitely yes, right. Cluster upgrades. If I have to go back to my portal and show you how we handle cluster updates, uh, similar to node pool upgrades, we can go to cluster configuration, and then click on upgrade version. You will be able to see all the supported versions in here. Now, when we can do this upgrade at three different scopes, right? You can do it across the complete cluster. It means that the control plane, including your node pools, or you can target it at the control plane only, or you can also do it at a node pool level. So if you go back to the node pool like we did for the node image update, you can select it and do it at the node pool level. But this is more um, this is more manual, right? So there are ways in which we can automate this mechanism as well, through auto upgrade channels. So we have a newer feature within AKS, which is called as auto upgrade channels, which are primarily like subscribing to a particular upgrade procedure, right? I've talked about it briefly in the node image upgrade as well. So we have like different options for the auto update channel. None obviously means you're not doing anything. You're saying, okay, subscribe to the latest patch available automatically. So you don't have to do anything. It automatically updates the cluster to the latest patch available. As I said, we support two patches in the minor version. So if you are on a particular minor version, we have released a third patch, which is the latest one. It automatically upgrades to the latest patch. Or you can either do a stable or a rapid, which is upgrading the cluster to the latest version. The stable is like taking it to the n minus version, whereas the rapid is as well taking it to the latest version that is available. As a part of the auto upgrade channel itself, you can see the node image upgrade. So if you want to use the node image upgrade auto channel instead of the GitHub actions, yeah, you're welcome to use that as well as a part of these auto upgrade channels.
Perfect. So, if these updates are automatic using auto upgrade channel, is there a way we can schedule them?
Yeah, definitely. It has been, yeah, anything unattended, again, it's a risk. We understand that it is a risk. If it is unattended, you wanted to have it either on a specific day or time because you have your support personnel available during that time frame or whatever it may be. So that's where planned maintenance comes into play. So once you enable planned maintenance on an AKS cluster, all your auto upgrades happen during that specific window. You can specify that all my maintenance has to happen on on Monday 1 to 2 a.m. So we make every effort to make sure that your auto upgrade happens within this specific time frame. So if you are using auto upgrade channels, definitely make use of planned maintenance window. That way you are in control of when that particular upgrade happens. Again, there's another variant of planned maintenance, which is for updates. I've talked about at the beginning that there are updates which happen which are unattended. So you don't have to do anything for it. But again, you might be worried that something is happening on a cluster during your business time, right? You don't want something operational happening on your cluster during your business. So that's where you can also say that the AKS updates that happens, the weekly releases that happens, should also be placed within a particular time frame, maybe a non-business hour or a time when your support is available. So that way you are on utmost control of when your cluster upgrades happens, or when something is happening behind the scenes from an operations perspective.
So on this auto upgrade channel, from what is our recommended best practices, Srini, from a doing it in a production versus a non-production environment? It seems scary doing an auto upgrade in production. Would you recommend that?
True. Again, it is a little difficult when you wanted to apply it across, but I would definitely recommend this for non-production environments, because that's where you wanted to spend less of your operational effort on. But production, I would be a little cautious here. I would not directly do an auto upgrade. I will use that on a lower environment from a testing perspective, or to see if something breaks or something, or to get to be notified that something is available, and and do it in a more controlled way in my production environments.
Perfect. So you'll upgrade, let it auto upgrade if you have more than one cluster, and test your application. And then when you feel comfortable on a, find a time for a production and upgrade during the time zone.
True. Right.
Perfect. Thank you.
All right. So moving on. Yeah, I think we are into the business continuity and disaster recovery section. Yeah, I'll hand over to you, Umar, to take it forward.
Perfect. All right. Thanks, Srini. That's a lot of recommendation, best practices, and thanks for all that recommendations. So now we're going to look into the last module of our session today, which is business continuity and disaster recovery. So when it comes to the business continuity and disaster recovery, one of the key um, decision in order for you to make, well, I'm going to talk about a couple of options, deploying across availability zones, across regions, or reprovisioning your cluster during a disaster using infrastructure as a code. How do you determine what is my strategy, you as a
That's
customer?
yeah, that's definitely something which I was about to ask you, right? What? Yes, if I start something a new journey of BCDR, what do you think are the core things that I need to take care of even before I get into the BCDR journey?
Yeah, it is actually, I would say, partly a business conversation as well. That is like, you need to know non-functional requirement. What are you exactly promising to your business? Meaning, what is your SLA, service level agreement, that you promising to your business? That determining that, and also understanding RPO and RTO. For instance, recovery time objective. During a disaster, how long can you be down? Right? Can you be down for only 1 hour, 2 hour, maybe like 8 hour? You can be down without any challenges. It's possible, right? Or during a disaster, how much of a data are you willing to lose, right? It might be scary, but recovery point objective. There are maybe losing a data for 5 minutes, 10 minutes would be fine. If that is the case, based on those things, right? Then you determine am I going to deploy across multiple region or availability zones, or I am going to reprovision my cluster? Sometimes the customers might say, having 5 minutes downtime application, my cluster going down would have hundreds and thousands of dollars I'm going to be losing in business. In that case, we would recommend them a different DRs strategy versus I'm okay, I'm running only a workload which are fine being down for 5 6 hours. Then there is a different strategy, right? It is going back to that what do you call the trade-off. As you as an administrator working with an architect, you do the trade-off. Of course, having deployed a cluster across multiple regions is going to increase the cost, right? So you wanted to think through that. So basically,
Great conceptual overview, but what do I have for AKS in store to achieve most of this?
yeah, so there are a couple of strategies that I'm going to talk about, whether you can just deploy it across availability zones or you can deploy across regions, that I'm going to talk about it. Before I jump into any of this, right, there is something called uptime SLA. That is something we offer. We recommend when you deploy a cluster in production, we highly recommend a production cluster use this feature called uptime SLA. Um, so to explain that uptime SLA, I'm going to go back to that architecture diagram I shared at the beginning of the presentation. So as you see, the Kubernetes cluster is, on the left-hand side is Azure managed, which is control plane is Azure managed. And this is on the right-hand side, the nodes are customer managed. So there is an SLA. There are two different SLAs. One, control plane, Microsoft offers an SLA. There is a two tiers of SLA. One is a free tier, which is 99.9, and the other one, the uptime SLA, is a paid tier, which is cost 99.95. Right, that let me show you this one. So that is the control plane SLA. But then you also have your agent node SLA. These agent nodes are follows your typical virtual machine scale set SLA. If you deploy across two availability zone, you get 99.95. Versus if you deploy just in availability set, not in availability zones, then you get 99 point. Sorry, if you deploy across availability zones, you get 4 nines for agent nodes. And if you just deployed in availability sets, only two nodes without availability zones, you get 99.95. To summarize, what I had done was just make it easier. I put this table in here. Like I said, this is a control plane. On the top table and the bottom table, you have agent nodes. Let's look at the control plane. Like I said, this is the uptime SLA. It's a paid tier. When you deploy your agent nodes across availability zones with the uptime SLA turned on, which I'm going to show you in a minute, you get 99.95 SLA for a control plane. Without availability zone, agent nodes are not in availability zone, but you're paying for uptime SLA. You get the control plane of 99.9. Okay. And by the way, this is all these numbers are documented, which I'm going to show in a minute. We still offer the free SKU tier. The control plane, you do not have to pay for it. It's a free tier, which you can use it for dev test clusters, and that you get 99.5 SLA. Now, moving on to the agent nodes, which is on the right-hand side, that architecture diagram, you get with the availability zones, if you deploy your agent nodes across two availability zones, at least two availability zones, you get the 4 nines. Without availability zones, you get the 99.95. So knowing this would help what you are going to promise to your business. Okay. So now let me go back to so now let me show you this uptime SLA. So how do you achieve this uptime SLA? Okay, so if I scroll down in this diagram, in this document, it's very simple. And if you were to create a new cluster, you would start pass in a parameter called dash dash uptime SLA, right? By doing this, and you're signing up for a paid tier. And this is another question. Hey, if I am not in an uptime SLA tier, is it possible that for an existing cluster, can I add into an uptime SLA tier? Yes, it's possible. Again, you do AKS update and you give a cluster name and you pass in the parameter dash dash uptime SLA that allows you to convert your existing cluster, which is not part of uptime SLA, into an uptime SLA. So now that you understand the uptime SLA at a high level, the agent nodes as well as your control plane, now let's look into deploying your cluster across availability zones. Our again, another recommendation when you deploy your cluster in production, we recommend that you deploy your cluster across availability zones. So how do you do that? So, and again, this is pretty straightforward as well. And when you go into this document, here are the regions that allows availability zones. There are more and more regions being added every day. But before I jump into the availability zone, let me talk about what is availability zone. Um, Availability zone is a unique physical location within a region, which is each availability zone is equipped of independent power, cooling, and networking. So one availability zone going down would not affect, maybe it could go down because of natural calamity, or it could be go down because of the power outage or cooling or networking. It should not affect the availability. Let's say one is going down, two and three shouldn't get affected. So they are an independent physical location and they are separated by certain distance. And now, how would you go ahead and deploy your AKS cluster across availability zones? So it's again pretty straightforward. I'm showing a CLI command, AKS create, and you pass in, zone parameter, right? If you're deploying in only two zones, you can do 1 and 2. If you're deploying across 3 zones, you can do 1, 2, and 3. And when you do, say, here are my 3 nodes, which is going to be spread across 3 availability zones. Kubernetes takes care of, AKS takes care of spreading these nodes across 3 availability zones.
So Umar, like what you have mentioned for uptime SLA, where you can update it on an existing cluster. Is
Correct.
it possible for us to update the availability zones after I create a cluster?
Unfortunately, not. The decision of deploying your cluster across availability zone has to be made up ahead of time. That is, at the cluster creation. Once you create the cluster, there is no way to convert that existing cluster to move into an availability zone. So it is a
Okay,
decision that has to be made ahead of time.
good to
So
know.
generally best practice is if you have gone in there without availability zone that you need to convert, you you know, ideally you should create a new cluster, deploy it, move your workload basically into there. It should be relatively easy because we recommend not to store the state in the cluster. If you're not, then it makes it life easier.
So you said that availability zones are more region specific. So
Correct.
if I have to be prepared for me losing a complete region, how do I go about doing it?
Yes. So that's where this, like I said, availability. If you deploy your application across availability zones, you get the 4 nines. Sometimes that is not the SLA may not be sufficient, or you have the fear of that zone is going down, like you said, Srini. And our recommendation is to deploy a cluster across two different regions. And there is we have a good documentation in here. It talks about how you would go about deploying in a multi-region. And also while you're deploying, you want to consider about a paired region. And I'm going to come to a paired region concept. The question is, hey, I'm going to deploy in a two region, primary region one and primary region two. Let's say this is going to be my East US is primary region. How do I select my secondary region? That's where we recommend something called paired region concept. Let me click on it. So paired region are kind of, when you go in here, it kind of lists down what is a paired region for each of the region. Paired region is a concept. During an outage, Microsoft will ensure one of those paired region, right? In that two region that you selected, one of them we'll prioritize, we'll make sure one of them come up and running first as we are prioritizing. If it, again, it's not a regional outages are not common. If it does happen, we'll make sure that it gets one of them gets prioritized. Okay. And the same time, when we're rolling out, Kubernetes updates, the upstream Kubernetes version updates, and all agent updates, when we're doing that, we will ensure that we're not patching both region at the same time. We'll patch, we will upgrade clusters in one region, primary region first. If that's successful, then only we'll move on to second region. We'll stack them. So we learned a lot of lessons from the past experience. So we'll make sure that out of these two region, only one gets selected first, done first and successfully, then we'll move on to the second region.
It looks like this is a little advanced. So what additional recommendations do you have, or what should I do additionally to make sure that I can deploy it across both regions?
Yeah, so I'm going to come to that. Just keep in mind for East US, the paired region is going to be West US. For a West US 2, the West Central US, the paired region. So you want to come to this table and find out your paired region. Once you know which region you're going, now what our recommendation is, go ahead and introduce a traffic manager on top of your two clusters. Let's assume that you have deployed clusters on two regions. Right now, you introduce a traffic manager. This is not new. This is the same pattern that we followed even when we have virtual machines. If you have anything deployed a virtual machine on Azure, it's the same pattern. Traffic manager allows you to load balance across regions. It's a DNS based load balancer. What it does is basically it has the ability to route the traffic. If a traffic originates from customer traffic originates from East US, and the traffic will redirect the traffic to the cluster in East US. Or if it's closer to the West US, it goes to the West US. So that's a performance based uh, um, routing. Traffic manager allows you to do that. That's just one way of routing, but there are other ways of routing in traffic manager as well. So there are a couple of best practices when it comes to in here. It again depends on, do you want to keep these two clusters across region 1 and 2 active, or you wanted to do active, warm standby or cold standby. It's up to you on how to decide. You can completely keep one active as a one region is active, and only when it just goes down, and I'm going to bring this back. This is always in a standby, warm standby mode. That is, if I'm running 10 nodes in a primary region, one, and I'm going to be in the secondary region, I'll probably maybe run one or two nodes, and I'm going to leave, bare minimum nodes. When it fails over, I'll make sure that I'll bring it up. I'll scale out, right? There is a risk always. Keep in mind, when the region fails over, there are just customers like you, hundreds of customers failing over to the second region. They are all going and requesting for resources. You might be competing with hundreds of customers. So if you do not want that kind of situation to be in, we recommend that, whatever the primary region, number of nodes, we recommend that you run on a secondary region as well. Okay. And that's just at the cluster level. Now, what about your dependency components, right? You have your, in order for your cluster to function, you need a container registry. Again, in our case, we're talking about Azure Container Registry. No matter what container registry you're using, make sure that you also enable your container registry, geo-replicated container registry as well. So let me quickly show you my container registry. So I'm going to go to my container registry, one of my container registry. There are a couple of things I want you to notice in here. The first thing is it is deployed in West US 2, right? So my secondary region should be West Central US because that's my paired region. And also, in order for you to replicate your container registry, there is not much thing you need to do. The only thing you need to do is you're selecting the premium SKU. It is not available on non-premium SKUs. The next thing you want to do is you want to come down to a replication on your container registry. And then if you are, as long as you are in a premium SKU, you would be able to enable that, add a new secondary region. So you can click on add, which you can see here. My primary region is West US 2. My secondary region is West Central US. It's being already replicated, as you see in here. Blue tick mark and a green tick mark. And if you wanted to add a next region, you can, as simple as that, you can click on add and select your paired region and click create. And it automatically, within the time, depends on how much of a image is sitting in your container registry, it start replicating to a secondary region. It's as simple
Great.
as that.
So you're talking about deploying this across regions and multiple regions. Like, is there anything, any way in which we can make this easy, right, when it comes to deployment?
Yes. So, and this is where now what we do is there are two things, right? We highly recommend when you deploy your cluster on in production, we highly recommend you use infrastructure as a code. Infrastructure as a code. I think you probably might know, all of you might know most of it. It's like ARM templates or Bicep or Terraform or Ansible. There are many ways to codify your infrastructure. Using infrastructure as a code. So that's the first thing you wanted to do it, right? So another next one is to, once now you provisioned your cluster in a secondary region, right? During a disaster, I don't want to run an active cluster in a secondary region, maybe because of due to the cost, or I have more RTO or RPO. Then I can, when a region goes down, I'm able to go and create a cluster using infrastructure as a code. You can do that, but also now you need to deploy. You're responsible for deploying your application as well. So we recommend using a CI/CD to if you already have containerize, you push to the container registry your images. Now use a pipeline, CI/CD pipelines, to take those images and deploy to the secondary region. So again, first recommendation is to deploy your cluster across two regions in production. If it's something a cost concern, when a region goes down, you can always using infrastructure as a code to deploy the cluster and deploy the application. So that's great. But now, are there any even better way to deploy your workload, or even infrastructure updates, your cluster upgrades? There is something called GitOps. I'm going to show you GitOps. Um, so GitOps is this pretty new cool concept. What it does is basically it uses your GitHub repository or any Git repository as a source of truth to make sure that your cluster as well as your application is stays up to date. So anytime you have your cluster changes, somebody goes into your production cluster, or for that even for a dev test cluster, they are manually updating your cluster. They're changing a node count, or they're changing the pod replicas count. If they do any of that, if you're following a GitOps methodology, what it does is basically it ensures that source of truth gets synced to the cluster from the GitHub repo. If your cluster configuration sits in the GitHub repo states that I should only run on a 4 nodes, and you auto scaled manually in your production cluster, or your pods are auto scaled manually, it'll ensure that it will reflect, it will change back to what's stated in the GitHub in your Git repo. So that's a GitOps. As Srini asked, is there a better way to deploy my cluster configuration, my application on the cluster? Our recommendation is use from an application deployment or cluster configuration, use a GitOps. Or
Definitely,
GitOps,
yeah, GitOps looks to be much more easy. Yeah.
yep. Our GitOps implementation is based on Flux V2. It supports, if you not only Kubernetes clusters running on AKS, or it also if you have any clusters, Arc-enabled clusters, the clusters running in your on-prem, or clusters running in another competitor cloud like GCP or AWS, you can enable the GitOps on those by GitOps on them as well by onboarding the cluster into Arc-enabled Kubernetes. So enabling a GitOps is very easy for a given cluster. For if you wanted to deploy a workload or a cluster configuration, right? It's pretty easy. There are some prerequisites. Simply deploying some CLI extensions like this Kubernetes extension and Kubernetes configuration. Once you do that, this is that main command. If you scroll down a bit in here, this is that main command which allows you to deploy this GitHub repo, sync with the GitHub repo, basically. So like I said, anytime a cluster gets drifted, it will sync back to the what you have in this repo according to that, right? This configuration goes into details of how you would do that. It's pretty straightforward doing this.
Great. So, what other considerations do you think Umar will have to take for BCDR?
Yeah, so one other main concern customers have is, like I said at the beginning, we recommend not to store the state of a cluster, right, inside the cluster. Externalize the state always, meaning push your state of your cluster into a database or a file share or externalize, right? If you externalize, you're only running a compute of the workload in the cluster, right? So in that case, it's easy for you to fail over to a secondary region because everything, your database is always replicated to another region. Your storage is always replicated to another region. It's easy. But the moment there are some situations that you cannot get away with it, you need to store your state. You need in the cluster some sort of a disk storage and like that. So then what we recommend here is if you have a situation that you have to store the state in your disk, you need a disk storage. We recommend something called ZRS disk, zonal redundant storage disk, which can tolerate the zonal failures. So if one of the zone goes down, then the cluster, the disk, your pods will move to a secondary zone. At the same time, your disk will fail over to the secondary zone and get attached to the pods as well.
Good to know
So
about that because we had this limitation of disks not moving across availability zones earlier. Yeah, I think this is a
that's
pretty cool feature.
That's exactly that ZRS disk feature started supporting it. Unfortunately, ZRS disks are only supported as of now only in a 4 region. Last I checked, it's only supported in a 4 region. So that's where I had a couple of other options. There are third-party solutions like Rook, Ceph. There are, so they also have the ability to uh, zone redundant disks. They also have those third-party applications also has it. You may want to look into that as well.
Great.
So that with that, no matter which uh, BCDR strategy do you have, right? Whether you're deploying across availability zones, deploying across availability zones is not a DR because it's still a high availability. Deploying across region is more of a DR strategy. Or I wanted to reprovision everything during a disaster, right? And no matter which strategy you are going, our recommendation is to create a plan, and make sure that you at least rehearse this regularly, so that way uh, you know um, so you're ready for a disaster. Again, if you have a secondary cluster, like second running in a secondary region, make sure that every time you push updates to a primary region, make sure that you push the same updates to the secondary region as well.
This has been great information, Umar. Thank you.
Perfect. Thanks, Srini. So, like I said, Srini had already showed this checklist. If you see this link, aka.ms/FTA as a service, AAS, and this allows not only talks about the operational items that we discussed in the call today, and there are other checklist items. We have it as well, meaning networking. There are lots of questions comes in during networking, how you design your AKS cluster following a networking best practices, security best practices, governance. So you have a lot of these checklist items are there. So just to summarize, we discussed how resource management works in Kubernetes. That is how you would define your request resource and limits for your pods, and how you would auto scale using horizontal pod autoscaler, how you would auto scale your nodes. So those are the things we looked into the resource management section. Then we also looked into patching and upgrading, how you would patch your agent nodes and how you upgrade your Kubernetes cluster. Finally, we looked into BCDR strategies, right? How you deploy across availability zones, how you deploy across regions, how do you geo-replicate your container registry, how you geo-replicate your disks. Um, those are some of the things we looked at it. And again, all the content that we discussed is available in this link, along with a bunch of videos. And don't miss our next session called Microsoft Identity Platform, which is going to be on November 15th at 10 a.m. Pacific time. With that, thank you so much for all joining our AKS Operations Best Practices session. We'll look forward to seeing you in our next session, Microsoft Identity Platform. Thank you so much.
Thank you. Thank you all.